Good evening, folks, and welcome to tonight's Advent of Code live stream. Tonight we're going to be working on Day 21's puzzles. As always, I'll be working through these solutions in C++. If you have any questions or comments, feel free to drop those in the chat. I'll do my best to answer your questions. If you're watching the stream replay later on YouTube, feel free to leave a comment, and I'll try and answer your questions there. Just a little bit of housekeeping. So last night I forgot to actually make a recording of the live stream while I was doing it, but I kind of got stumped for a while and didn't have a solution by the end of the live stream. Called it a night, got some sleep, thought about the problem a little more, and then came up with some solutions that I actually quite like today. And I actually, having now gone through the whole process and solved the puzzle, I think yesterday's puzzles for day 20 were some of my favorite overall this year. But I posted a new video just a little while ago on my YouTube channel at youtube.com/spoonboy42, where I just walk through the solutions that I got for day 20's puzzles. So you can go ahead and find those right now on my YouTube channel. Same place where we have all of the stream replays. You can find the link in my profile here. As always, you can also find all the code that we write up in my GitHub repository. That's github.com/Craig-Chasseur/AOC2020. You can also find a link to the repo down in the description. So we have a little under 3 minutes until tonight's puzzles unlock. So why don't we just do our preliminaries here and set up a new directory for day 21's puzzles. We will make our very basic C++ program to start with. And we will make the build file to tell the build system that we're using, Basil, how to build it. And we will go ahead and build and run that and make sure everything is okay. Okay. Everything is fine, and because we have needed them almost every day, let's go ahead and just include the check and IO libraries that I have in my little repo here that I use for assertions and just to do file IO, because we often need these for these puzzles, so might as well just put them in ahead of time. Okay, go ahead and compile and run that one more time, and we are still good. So we have just about a minute before tonight's puzzle unlocks. You can see we're filling in more and more of the picture here. Here's the sea monster that we discovered in the last couple of nights' puzzles from the ELF spy satellite. And now we are finally making our way south to approach our ultimate island destination, which is somewhere down here for our vacation. Really cannot wait until vacations are a thing again. Very much looking forward to that. My parents are retired in Florida, and once it is safe to do so again, I'm really looking forward to going to visit them. Okay, just a few more seconds. The anticipation is building. Let's go. Allergen Assessment. The train's last stop and closest you can get to your vacation island without getting wet. There aren't any boats here. Oh, we build a raft. You need a few days worth of food for your journey. Don't speak the local language, so you can't read any ingredient list. However, sometimes allergens are listed in a language you do understand. Okay. Start by compiling a list of foods, one food per line. Each line includes an ingredients list, followed by some or all of the allergens which the food contains. Oh, some or all, not necessarily all. Each allergen is found in exactly one ingredient. Each ingredient contains 0 or 1 allergen. Allergens aren't always marked. When they're listed, the ingredient that contains each listed allergen will be somewhere in the list. However, even if an allergen isn't listed, the ingredient that contains that allergen could still be present. Maybe they forgot to label it. Maybe it was labeled in a language you don't know. Fascinating. Okay. First step is to determine which ingredients can't possibly contain any of the allergens in any food in your list. For example, none of the ingredients such, such, and such, counting the number of times any of these ingredients appear in any ingredients list produces 5. They all appear once except that. Okay. Determine which ingredients cannot possibly contain any of the allergens in their list. How many times do any of those ingredients appear? Okay. Let's get our puzzle input here. And let's go ahead and see just how big that input is. Okay. How many lines? Okay, 48 different lines. This is okay. So first thing we're going to need to do is just read in some of the input and parse it, and we can. Yeah, let's just write some basic parsing routines to start with, and we can see we can do some things like count the number of distinct ingredients and the number of distinct allergens, and just get an idea of how complicated this problem actually is. Got ingredients and allergens. We can just write a constructor for parsed food here that goes ahead and that goes ahead and parses that from a line of input. That should be explicit. So we want to split the line into the parts that is the ingredients in the language we don't understand, and then the allergen list in the language that we do understand. So we'll just say we'll split going to use abcell stir split here, and we're just going to split by space and then open paren, and that will get us the two parts of the input string. So there should be exactly two of those. And for the back part, we expect it to end with a closed paren, so and then we will just trim off that close paren from the end there. Well, actually, you know what? I'm going to make this delimiter even bigger because I just want things to be separated either by spaces or commas. So we'll just use that whole thing there. Remove that one close paren at the end. So, and ingredients equals that first part of the string, just with space separators between the ingredients. And allergens will be the remaining part of the back with comma space separating the parts. So what we can do here now is actually read the input file. We should expect that there are exactly 2 arguments, one for the program name itself and one for the file name that we're trying to read in. Do read lines from file to read all those lines. And then we will make a vector of foods. Okay. And then we can, well, so we'll go ahead and, count the number of foods. We'll say parse however many foods, which should be 48 for our puzzle input. We should have vector and string in here, and IOStream. And then another thing that I'm going to do is just build up sets of ingredients and allergens and see how many there are of each, just to get an idea of the size of this problem. Okay, so for each of those parsed foods, we will insert all of its ingredients and all of its allergens into these sets. Okay. Let's add these dependencies for flat hash set and abcel strings to our build file, and then see where we get. Go ahead and run that on our puzzle input. Okay, so we've got 8 distinct allergens, not that many, 200 distinct ingredients. Um, so, hmm. So now we need to, for part one, we need to find all the ingredients that can't possibly contain any of the contain any allergens. Now I wonder if we have to go all the way to the point where we actually determine which ingredient contains which allergen in order to solve this, or if we can do it in a simpler way. I'm also going to, just so we have test input, just go ahead and put in the example list here. You can see how we do for the test input as well. So let's try and make a map of allergens to the ingredients that they correspond to, to the ingredients that contain that allergen. Let's maybe have a class to represent allergen and the possible ingredients that it can match to, though. So we've got the name of the allergen. And we're also going to have a flat hash set of strings representing the possible ingredients that it could match to. And we'll have it initialize that list of possible ingredients by looking through the parsed foods. So name is going to start as just the passed in name. and we'll build up that list of possible ingredients. So we will say so the first time we find any parsed food that we know for sure contains this allergen, then we will initialize the set of possible ingredients to be all of the ingredients for that food. And then for each subsequent food we encounter that we know contains this allergen, we will filter down this set so that it's just the intersection for all those ingredients. Because anything that definitely contains this allergen has to contain the corresponding ingredient that has this allergen. So if we're in the allergen list, we actually want to do some processing, and we should include algorithm for standard find. There we go. It says it is not already initialized. We will insert everything into that possible ingredient set. And we will set that to true. Otherwise, we are going to start filtering things down. You know, because we're going to be doing this finding over vectors, again, I'm just going to make a little helper function that is going to make this easier. And we will just make it this, something like this. I'm going to make that, because then we can just write the shorthand contains instead of having to write out this call to standard find every time. So now this becomes if contains food.allergens name. And this is going to make it easier for us to filter out things from the possible ingredient set too. So we'll do erase if. And for our predicate, for the things we want to erase, we're going to have food captured in a lambda, captured by reference. And you want things to be erased from that set if they are not in the list of ingredients in that parsed food. Okay. We'll put in some accessors for this too. So the next thing I want to kind of try and find out is for each of the allergens, I want to see how many possible ingredients each one maps to. Because if we get a sequence like, if we find any of them that can only map to one, then that makes solving all the rest easier. And especially if we get, like one of those sequences like we saw on a previous day, like it's 1, 2, 3, 4, 5, 6, 7, 8, then, the solution falls into place very, very easily. So we'll leave these print statements in. I mean, we'll take them out eventually, probably, but for now, it's good to keep track of what we're doing as we're going. We have an error somewhere here. 32. Yep. There we go. Okay. So next thing to do. We'll change this from allergens to allergen names, because we'll use allergens as the name for the actual vector of instances of our allergen class. And we're going to want to make these strings. Kind of vacillated back and forth on, using string viewer strings, but these are all pretty short strings such that it doesn't really matter because, again, most good modern C++ standard library implementations will inline storage of small strings in the string class itself. And all these allergens and ingredients look to be pretty small strings. So we'll say const for allergen name and allergen names. We're going to place back a new instance of allergen with that allergen name and initialize from those foods. And we'll say we'll print out how many possible ingredients there are for that. So on the test input, we need to add a dependency for flat hash map before that'll build. Okay. So we say dairy has one possible ingredient, fish and soy both have two possible ingredients. Now, if we try that on our actual test input, let's see what it gives us. Nuts has 2, shellfish has 1. Okay. I wonder, So for part one, I mean, we're working towards a place where we can maybe figure out all of the allergens, but I wonder if just for part one, we can, if it's good enough to just remove all of the possible ingredients from that set of all ingredients, and if that gives us the answer for part one. So So we want to erase elements from ingredients if they are part of the possible ingredients for any of those allergens. So you write a little lambda to do this. As our predicate. Say for each allergen in allergens, if allergen dot possible ingredients dot contains that ingredient, return false. Otherwise, return true. Oh, no, return true because we should remove it, yes. Otherwise, return false because we should keep it. Okay. So let's once again run on the test input. It says 4 ingredients can't possibly contain allergens, which is okay. Which does match what we would expect from the input. So let's go ahead and just say to count ingredients in set, just to count everything up. So for each food in the list of foods, we will go through each ingredient in that list of ingredients, and we will increment total if that set contains that given ingredient. And so that will get us up to the count of all the appearances of those ingredients. Okay. So we could finally just do count ingredients and set with that filtered down ingredient set there and our list of foods. And that ought to be the final answer. So with the test input, that gives us 5, which is correct. So let's try it with our actual day 21 input. Gives us 2,786. Let's see if this kind of simple logic is good enough. All right, let's move on to part 2. Now that you've isolated the inert ingredients, you should have enough information to figure out which ingredient contains which allergen. Arrange the ingredients alphabetically by their allergen and separate them by commas to produce your canonical dangerous ingredient list. There should not be any spaces in your list. The above example, that would be that. Okay, we just have to give our canonical dangerous ingredient list. All right, so first thing I'm going to do is just copy over the part 1 solution to part 2. And we can start working on that. And now that we've copied that, I'm going to go ahead and copy this build target because part 2 is going to be starting in the same way. Go ahead and reload there. All right. Now, one thing that I'm going to do is we can take out, just some of these parsing lines because you don't super need them anymore. I mean, maybe we might want them again, but I also don't think we need this counting stuff to count up the inert ingredients. So now we know well, actually, let's print out those allergens again. Let's restore some of that printing because I think obviously we want to start with the most constrained, and then if there's any overlap, we can use that to rule out some other stuff. Yeah, so let's just run part 2 on our puzzle input and get reminded by, like how much each of these allergens. So shellfish, we know exactly what it has to be. And I am kind of hoping that there's overlap between shellfish and some of these other things such that we reduce the possible ingredients for each of them. So let's see here. We'll add this method to allergen where we just erase erase that ingredient. So yeah, what we want to do here is we'll make we want the possible ingredients for each allergen to constrain each other. So we'll just write a function we call it solve allergens, I guess. And the first thing we'll do is we'll loop through all of the allergens. And if we find one actually, we'll do an outer loop here that just keeps on going until we explicitly break it when we've when yeah. We'll have this solved vector, and anytime we get the number of possible allergens of possible ingredients for a given allergen down to 1, it goes on the solved vector because we don't need to process it anymore. So this input vector is not empty because eventually these will all be moved on to solved. So if the possible ingredients for a given allergen is only 1, then we move it to solved. Otherwise, we put it on unsolved. And once we've processed all of the allergens in that way, we remove all of the known matching ingredients from the unsolved. So we make another pass through unsolved. And then for all the solved ones, now because we're keeping this solved out of here, we will remove the same thing twice in this iteration. We could try to optimize that away, but I don't really think that it's necessary. We should check, of course, though, that solved allergen dot possible ingredients dot size is equal exactly to 1. And then we tell that unsolved allergen to remove that ingredient from the solved one. We'll just get that by dereferencing begin on it. That will give us the 1 element in the set. Then once we've done that, we replace allergens with unsolved. When we finally get to empty, we replace it with solved. So we'll say bool any new solved equals false. And we'll say any new solved equals true here, because if we didn't find anything new that was solved in a particular iteration of this loop, then it's just going to keep on going forever, and we're not going to get anywhere. So check any new solved. So hopefully this will give us the possible yeah, I think hopefully this will actually solve that like we want it to, just by process of elimination. So we do solve allergens, and then we want to sort the allergens according to alphabetically by their allergen, and then separate them by commas to produce our dangerous ingredient list. And so we'll write our little comparator here. Just compares them by their name. And then we will build up our, well, we can just do it with cout, really. Yeah. Just to make this a little easier, I'm going to write an accessor for the single possible ingredient. We need to check, of course, that there is only one, and then keep it in return. Okay. And then we can also make that a little simpler here. Use the single possible ingredient method there. So we'll do the first one there, and then each subsequent one we start at one past the beginning and just go through all the rest of them and put commas in between. And then new line at the end. Okay. Okay. If this process of elimination solver is good enough, then I think that this will give us our answer here. You can also get rid of that. Let's see how it does for the test input. Okay, that is correct for the test input. Let's try for our actual day 21 puzzle. Okay, let's see if we got it right. All right. Okay. So this one didn't get too stuck on this one. It's just kind of process of elimination, really, because and we had to do that in both parts. Let's see what our stats were on each of these. So yeah, low thousands on each part. Not bad. Definitely better than yesterday, where I stalled for a long while and then picked it up the next day. But I am pretty happy with tonight's solutions. I think this is a pretty fun puzzle. I think in both cases, the real key is that it is all about process of elimination. So, you know, in the very beginning, you know, for each allergen, you know, we figure out the common set of possible ingredients. You know, the ingredients that show up everywhere, that show up in every recipe or every food where that allergen exists. And then for part 2, we again use process of elimination. You know, we first find, okay, is there an allergen that has only one possible ingredient that corresponds to? Unfortunately, there is. And then we go through all the other allergens and say, well, we know that it can't be the same one that only matches one, because, you know, that one's already taken. So we take that out of the set of possible allergens for all the rest of them, and we just repeat that process. We find the allergen that could have only one possible ingredient that it matches, and, you know, each time we solve one allergen, we reduce the space of possible solutions for all the rest of them until finally there is only one possible ingredient for each allergen. And then we just, you know, as the instructions in the puzzle say, we sort the allergens alphabetically by their names and then print out our canonical string of ingredients. So, yeah. Process of elimination, you know, find the thing that's most constrained, solve that, and then use that to further narrow the solution space for everything else. So, yeah, I thought this was a pretty fun one. I hope you all enjoyed solving this puzzle together with me tonight. I will, as always, post the stream replays up on my YouTube channel at youtube.com/spoonboy42. You can see replays for every day of Advent of Code there. You can also see all the code for all my solutions up in my GitHub repository at github.com/craig-chasseur/AOC2020. All these links will be down in the description on the video. Thanks again for joining me tonight. I look forward to seeing you again for tomorrow night's puzzles. Bye-bye, everyone.